is officially about Venn diagrams, but we're going to start with yesterday's because I find a lot of kids have more trouble actually with these tree diagrams than they do with the Venns. So we're going to do a review. And I started the hour by asking how many of the class, which is 28 people, how many of them were boys. We had 14, which makes it really obvious what the girl part should be. So you should go ahead and fill in this fraction right there. Then how about my next question is different. If I got a boy, as like I randomly picked and then it turned out to be a boy, then the question is, do they have a dog or not? Okay, and I found a lot of people have dogs, so it's actually going to be faster for me to count up. Raise your hand if you are a boy, but you do not have a dog at home. 1, 2, 3. Okay. This is dog. This is not. And there were 3. But 3, think about it, was it out of 28? No. 3 out of 14. You should be able to fill in the rest of this chart, including the final thing, which is like, this is a boy with a dog. We're going to call it a B dog. And a boy that does not have a dog, called a B not. And you should be able to give me the decimal probabilities for them. Now, for the girls, I do need to get us a little bit more info. And that's dog or not. And again, I find there's more kids that have dogs than not. So I'm going to count the faster one. How many of you are a girl but do not have a dog at home? 1, 2, 3. All right. So then 3. Don't feel bad. Some of them might have a pot-bellied pig. You know, like they might have some other thing cooler than a dog. All right. So would you please fill in the rest of this chart? You have all the info you need. First of all, you might be saying, but we don't know how many girls there are. You can figure it out from the chart based on the fact there's 28 people in the class. All right, so I'm going to pause for a moment while you finish this chart up, and your answers are going to be like this: 17, 83, 49, and 57. That would be terrible because you're supposed to add up to 1, but something like that. All right, I'm going to pause while you work on the chart. Okay. 14 out of 28 here. And if there are 28 total humans and 14 of them are girls, then this is 3 out of 14. And the other must be 11 out of 14. Because these together have to make a total of 14 out of 14. So do these. And so that means, again, 11 out of 14. And then this is the part where, without a calculator, you pretty much can't do it. But would you please tell me the top number, B dogs? And we're going to say Dice of Destiny to see this. If you don't have it, you'll have to figure it out. Row 4, person 5. Back spots. What'd you get? Top number. Have you not got it yet? Grab your calculator, hurry up. All right. Sensing a new seat coming for you soon. Row 5, person 1. We're going to get a different take on this. That's going to be right here. What'd you get for that? Not the top number because he's already figuring that out. Second number. Oh, for Pete's sakes. All right, I'm going to pause for another minute, give you more time, because obviously some of you didn't have the time to get this done. Can anybody verify that? 0.39. Thank you very much. 0.39. And then the B not. What'd you get? Say it. 0.11. All right. And let's go over here. Well, come on. You didn't do the other ones now? Can catch up. Okay. Oh, look at that. Okay, then you better do the last one. Because the last one's not the same. G not? Oh, I see what you mean. Okay, I get you. Okay, you're right. In this case, these charts normally don't do this. But because of the fact that the number of people that did not have a dog was the same on for both boys and girls, you're right. It ends up being the same. Okay, so at least use logic to tell me the answers.
It's 439.
And this is G what? G dog.
All
right. G not. 0.11. What are these supposed to add up to? What if they were off by like 0.1? What would that be because of? Rounding. Okay, good. So, I'm not saying these are off. These actually worked. But now here's the tough part. Way tougher than what we just did, actually. That was all just like little logic questions. Easy. This one you actually have to know rules of probability to get them right. All right, so the first question, I'll give you a softball. What is the probability that I get a kid with a dog? If I randomly select from a kid in the room, what's the probability I will get a kid with a dog? Don't say it, write it. Number one, probability, and they would just say dog, because the kid would be assumed. I didn't make it quite as easy as just B dog, because it's right there. All right? But kid with a dog? Now, some of you are not sure whether you should add them. We should, like, some maybe you should add them and divide by something. All right, so boy with the dog, girl with the dog, when you put them together, you get 30, 60, 78. Raise your hand if you had 0.78. Okay, but if you didn't divide by something, you're not understanding it totally. I want you to just understand this. The 0.39 plus the 0.39 is what you wanted. What was it out of? Yeah, it was out of everybody was possible, so that I'll add it up to 1. Now, I know you don't have to show me that divide by 1, but it's going to matter on the next question because what it's out of is going to change. It's not going to be out of 1. How could it not be out of 1? Because here's the question. What is the probability of dog slash girl? That does not mean a girl with a dog. The slash means given, and it's given the next thing. So I'll say it to you the right way. Given that it's going to be a girl, then what's the probability that they will have a dog? Now that changes what it's out of. It's not out of everybody. We didn't pick from everybody. But if all you do is find G-dog, girl with dog, you're doing it wrong. Do you get that this is kind of part of your answer? All right, now there's 2 ways you could do this, and I will accept either one as a right answer. But if you want, given that it's got to be a girl, then you don't take it out of everyone like this, where we added up everyone and it added up to 1. We say it's 0.39 here. I'm going to do my answer where there's some space here. It's 0.39 is what I wanted, but it's out of what was possible, which was these two together, which is 0.39 plus 0.11. I want you to process that for a second. The only things that were possible, because it was given that it had to be a girl, was this and this. So those two together are what's possible, and that's why the bottom is that. Now, there's another way to do it, but I'm warning you, the way I just showed you is the powerful way. You need to learn that way. Now, you could argue this. Mr. Server, if I was given that it was a girl, then I went down this road, and then I just found the probability of dog from there, which was this 11/14. You know what? It's the same exact answer as what we're going to get. When you actually divide this out, the decimal is the same as the 11/14. So that 11/14 is right, but the other way was a powerful way to learn how to do it. So I want you to do one more like I just did. Okay? So this time, it's given that there's a dog, probability, given that there is a dog involved, that's the slash dog, and what's the probability of not? Don't say it out loud, think it through. Pause while you try this. This one can be confusing, no doubt. As soon as I said given that there's a dog involved, then I changed what was possible. Not everything was possible. Only the dog ones were possible, which is this one and this one. 0.39 and 0.39. Those are the things that are possible. But what did I want? I wanted not, which aren't even in the possible. Those aren't ones I can pick. If I can only pick from these two things, and then I want to not have a dog, what's the probability of not having a dog, given I'm only going to be picking people that have dogs? 0. Final answer is 0. I know. That's what you have to wade through. These get confusing. All right, I'm going to clean up my chart again and ask you one more summary question. And we'll see if you get this right. I'll pause. Okay, so I'm going to ask you one last question. I'm going to call it question Q. So, given, this is probability, I'm not going to even say what, given that I did not be dog, I'm not going to pick a person who's a boy with a dog, then what's the probability of not? Remember, you always do these as what you want over what's possible. I know, and you have to wade through it. I'm going to say it again. Given that I am not going to pick a boy with a dog, then, because this is the given sign and this is what it's given, given I'm not going to pick a boy with a dog, then what's the probability that I will get a person who does not have a dog? You can pause while you figure that one out. Remember, it's what you want over what's possible. It's like a little fraction here. All right. So, what you want over what's possible. I'm going to start with what's possible. If it's given that I'm not going to pick a boy with a dog, then that's out, right? Then everything else is possible. So I take those three and I add them up and I put them on the bottom. 0.11 plus 0.39 plus another 0.11. That's what's on the bottom. And now, if you save me some time, what does that add up to? 61%? 6.61 adds up on the bottom. Those are the three things that were possible, and they go on the bottom. That was this, this, and this were possible. Okay, then what I want should go on top. What do I want? I want not. Why am I not picking this one? Well, they had a dog in the first place, so they wouldn't be a not, because it's not even in the things that are possible. That and that are the nots. That's what I wanted. Those go on top. 11 and 11 makes 22. So you should have had 22 over, what did you say this added up to? 61? So whatever 0.22 divided by 0.61 comes out to? Like 30-some percent? 36%. Or 0.36. Raise your hand if you had that one right. Awesome. That is a really tough one. I get that that's really tough. But we've covered pretty much anything we could torture you with when it comes to those probability trees. All right. Now let's talk about Venn diagrams. So Mr. John Venn actually created the Venn diagram. That's what we call them that. And I think you understand them from the past, but I'm going to make one with you right now that'll help you understand. iPhones, dogs. Okay? If you don't have an iPhone, you probably have an Android, because almost everybody has a smartphone by now. I'm not saying everybody, okay, but I did just read a stat that boggled my mind. Half of every number of human adults, that's to clarify adults, half of all the adults in the world have a smartphone now. Not just a cell phone, a smartphone. And that blew my mind. I mean, I'm thinking, I know people myself that don't have a smartphone. That just have a dumb phone, like they have a cell phone, but it's not a smartphone. And like, how could it be possible when you add in all the people in the world? Remember, this is another stat that goes with that, a little math behind it on the side. Half of the world's population lives on $2 a day or less. Half of the population of the world survives on $2 a day or less than that. And there's a lot of those people who aren't going to have a smartphone, but there must be some of them that do, right? In fact, I've actually heard in some countries it's more popular to exchange money with their smartphone than it is to actually hand money out. In some poor countries, it actually works better for them to trade money, kind of like Bitcoin, except it's not Bitcoin, but they actually, some very poor people trade their money digitally on phones, like kind of with Bitcoin. I know that seems like, how's that possible? But when I heard that half of all the adults, all of the adults in the whole world have a smartphone, it made me realize, whoa, this is really not just a, like here in Minnesota, pretty much everybody has a cell phone thing. It's got to need to be that way around the whole world. Yes?
So if you have, if say, my dad's friend like is using an iPhone 3, would that still really be considered?
It would be still considered a smartphone because here's the definition of smartphone that I would think they would have used, is that it can access the internet. Okay, because if it can access the internet, I know an old phone is still, but hey, if you can like access the internet, you can look up, sports scores or whatever, obviously the internet gives you access to a ton of things. If you can look stuff up on your phone, like real time, not just stuff that's on your phone, then it's a smartphone. Anyway, so iPhone, dog, neither. Now, remember, I'm not saying smartphone, I'm changing it to iPhone because pretty much everybody in here will have a smartphone, but not everybody will have an iPhone. All right, so if you are a person who has an iPhone, you would be here and here. Wait a minute, you have to be in one or the other. So my point is, if I had just asked how many have an iPhone, and there's 28 of you in here, and let's say 25 of you said you have an iPhone, if I put it there, that's not being smart. Because some of them will have a dog too. So I shouldn't just ask who has an iPhone. What I should ask is, maybe first I should ask who has an iPhone and a dog, and that goes here. Raise your hand if you have an iPhone and, okay, that was a bad question, but I got to count them. Okay, 2, 4, 6, 8, 10, 12. Okay, 14, 16, 18, 20, 22. Thank you. Now, I'm going to ask the other part that's easy, and that is this spot. And how do I ask that question? Who has a dog but not an iPhone? Raise your hand if you have a dog but not an iPhone. Oh, interesting. So everybody that has an iPhone, or no, everybody that has a dog has an iPhone. Interesting. All right. So I'm going to put a 0 here then. How about this one? The neithers, because once I know that, I can deduce the other number. Who does not have an iPhone and also does not have a dog? No iPhone, no dog. All right, one person. Okay. Now the cool part is, since I know there's 28 of you, I'm going to put a 28 right there. Everybody should do that. Upper left-hand corner is where the total goes. Then, use a little logic to figure out the last spot. What's it got to be? I could have. You're right. I could have. You're right. I should have done that, in fact, because it would have been quicker. All right. Did you get 5 people would have said yes here? And if I had it to do over again, maybe next hour I will, I would just ask those 3 spots, and then we could figure out the last spot from it, right? All right. What do you think the most common mistake here is? If I say there's 12 people that have an iPhone, people want to go, oh, so you said to put a 12 here. Nope. If there's 12 people that have an iPhone, some of them are going to have a dog and some aren't. That means together this and this would have to add up to 12. See what I'm saying? So making the Venn diagram is more complicated than you'd think, because you think I'm not just going to give you all these numbers. I'm going to give you some of the numbers. All right. Then, here's some questions about this frequency Venn diagram. What is the probability that I will select somebody that has a dog? Don't say it. Write it. It's a fraction. Probability, dog. Did I say any givens that would change what it's out of? No. So therefore, it's ought to be out of 28. And then it's easy. Just find the one where the dog is, and it's 0. No. These two together make the dog area. So it's 22 out of 28. Raise your hand if you had that one right. Okay, awesome. Next, we'll find the probability of iPhone given no dog. Remember, I just changed it. It's not out of 28 anymore. As soon as I say given something, then that means it's changing the denominator. It's not out of 28. Given that they have no dog, the person I'm picking is going to have no dog. Then find the probability of the iPhone. All right, this is a tricky question. Given that they have no dog, do you get I'm really only picking from these 6 people then? Get what I'm saying? So then it's out of 6. And now, what's the probability that they have an iPhone? Well, what I want is the iPhone, and that's this, because that's the only one I can pick. I can't pick those because they're not in the given. So I have to pick this, so it's 5 out of 6. Raise your hand if you had 5 out of 6. Okay, good. All right. Now, how do you make this thing into a probability Venn? It's really simple. You take all the numbers that are in here, and what do you think you divide them by? 28. So this is 5 out of 28. This one's 22 out of 28. Of course, you could make those decimals if you wanted. 0 out of 28, which is 0, of course, and 1 out of 28. So the probability Venn just divides them all by 22. It's easy. 28, sorry. Okay. So now let's look at one that's already made up. This is math and science, and this is not the way real world is, because at our school anyway, if you have math, you pretty much have science. There are some seniors who opt to not take math, but it's really rare because most colleges nowadays require 4 years of math. Okay, so it's pretty rare to not have a math class. It's also pretty rare to not have a science class. And just out of curiosity, in this room, is there anybody, I don't know, I'll say it this way. How about this? Who is taking a science class? Raise your hand if you are taking a science class. Okay, good. So you'll find that almost everybody at our school. So this is not how our school is. But imagine for a moment that this is amongst seniors, and maybe it's amongst seniors who are not headed to college. Then all of a sudden, yeah, there's going to be some that don't take science, and there's going to be some that don't take math. There's going to be some that aren't taking math or science. All right? So now, given this is a probability, unless there's a 0.4 of a person running around somewhere, this must be a probability then, right? Then, M represents the event that a student is enrolled in math. S is the one about science. What do each of the 4 regions represent? That's a little too easy. Except, some people do get this confused. Is this math and science, or are they math or science? All right. So, let me ask this question then. Probability of math is pretty easy, except do you get that some people are going to say 0.4 and be wrong? It's actually 0.7 is the probability of math, because you got to remember this isn't math totally. That's some of the math people. That's the rest of the math people. Together is your answer. Okay, how about probability of science then? Use the same exact logic. 0.5, because you got to put these and these together. Okay, then how about the ors and the ands? That's where people get confused. I told you this on the first day that it's kind of counterintuitive. Ors give you big answers. ands give you small answers. And if you just do a quick in your head, like, I win if I get this ticket or this ticket or this ticket hits, see what I mean? My probability is going up with an or. If I say and, I've got to win to find a person who has a dog and an iPhone and drives an SUV. Okay, then my probability kept going down every time I said and. So ands are small answers, ors are big answers. So knowing that, what's the probability of math and science? 0.3. And this is the sign for and. I would think of it this way. Here, I'm going to blow it up. See what I did there? And, get it? It's like the N in and. Okay, fine. Memorize it any way you want to. You don't need the M and the S. Okay, now does that help? Okay, the N is like an A, N, D. Okay, and then the other one is for or. Take a wild guess what that. Oh, you see it already. That's the symbol for or. It's the other way around. See what I mean? One of them was upside down, one was right side up. Okay, this was, I like to think of it as a U. And U just stand for union. And that'll make sense. U and union. And union is like the Union of the United States of America. We are all one big country that stands together in the event of war, etc. We are separate states. Like Texas is totally different than Arizona. But we are a union, as in we all work together. Again, at the beginning it was like for defense. You know, do you think Massachusetts could have by itself been able to take on all of Great Britain and the biggest navy in the world, et cetera, et cetera? No. We couldn't have even done it without France. We couldn't be a country right now if France hadn't helped us out. Now, we did return the favor a couple times since then, like World War II, but France has been one of our best allies over the years, really, if you think about it, because we couldn't exist without France. And there's been more than once where we came back and helped them out, and they would have been taken over if it wasn't for us. Okay, so union. A union is like, if I say the dog owners, it would mean all of the dog owners, whether they had iPhones or not or whatever. The union is like all of them. Okay, so or are big answers. So given that, a lot of people are not sure about this middle area. You have to decide if you think that's included or not. Okay, but if I say what's the probability of math or science, is it all three of them? Is it just the outside ones? That's what you have to decide. Write down what you think the answer to this question is. And it'll really boil down to that middle section. And here's a way you could answer it before I even tell you what the answer is. Ask them. These are people, right? There's people that are taking these classes. You ask them, do you have math or science? And then see what they would say. Okay? Think of it that way. Do you have math or science? And they would say, yeah, I do. Do you have math or a science class? And they'd say, yeah. Do you have a math or a science class? They would say yes. Unless they were being a real jerk and say, no, I have a math and a science class. I know that's what some of you are going to be bothered by, but the fact is, bottom line, all three of them are included. So final answer, 4, 5, 6, 7, 8, 9.9. And if you wanted to put it what it's out of everything, which is all of them added up. But that adds up to 1.0. So dividing by 1 doesn't do much. So final answer, 0.9. Okay. Remember me saying ors are big answers? It's bigger when you include the ones in the middle. That's one of the reasons I say ors are big answers. Okay. Moving on. Probability not S. If it's not these, it's really kind of cool to just scribble them out. If it's not them, well, then what's left? Those two, which makes 0.5. That's called the complement of S. That means what was not in S. Have you heard that saying? You complete me. Well, it's like a husband-wife combination. You and your partner sometimes are like strong where the other is weak. You complement each other, as in, I'm like really good at this, and my wife's really good at that, and so together our strengths complement each other. Whatever I'm good at, she's not, and vice versa. Although it's not that simple, of course. We can both drive, but I might be good at this where she's really good at that. And a lot of times, my theory is that once you get married to somebody, that you kind of tend to like separate into like, I focus on this stuff and I get really good at that, and the other person focuses on other stuff. Like for instance, I have been the person in charge of the like long-term investments between the two of us. So I really think about that a lot and I focus on it. And in turn, she has been in charge of, for instance, our landscaping in our yard. And so she's the one who thinks about where should we put the trees and where should we plant, should we put in a garden over here or there? And she makes those calls, and I don't think about that stuff very much. We get better at it over time, and you kind of get focused on it. So a complement, I wanted you to think of this as not just a math term. The complement of S is everything that's not in S. It's all the other stuff. Okay, so then try to turn this around. What's the complement of math? It's actually an answer. Complement of math. That's like saying everything that's not math, which is those two, which is 0.3. Raise your hand if you knew that. Okay, good. All right, moving on. And we are getting low on time here because I want to hand you your test back. I think you'd be able to handle these from here on. The only other thing I got to show you is this. If this has to be changed from a percent to a number of people, do you get this as 40%? 40% of the 100 would be 40. See what I mean? And of means times. So if we hadn't made this nice, we had made this like 86 people, you could still go 0.4 times, of means times, 0.4 times the 86, and then you'd put the number in there. Okay, so they're pretty easy to change from a probability Venn to a frequency Venn. You just times by how many people there are. Okay, so this is very unusual to have two complete separate circles where they don't touch. But if I said freshmen and sophomores, is there anybody who's a freshman, sophomore? In college, you actually can be, because you can be in your freshman year but taking sophomore level courses. A lot of you will be. If you looked at this in college, there are people who are freshmen, but yet by credits, they're a sophomore. So you can actually mix these two. There's a lot of things that can be mixed. There's not many that say completely separate. Light and day. Well, what about dusk? It's part light, part day, right? Not many things that are mutually exclusive. Okay, your homework is, oh, I like this one. If you've ever heard the song, with or without you. Anyway, I can't live. All right, anyway, so your homework for tonight, I'd like you to do the evens on that worksheet, and there is an answer key already posted this time, and that's all I got for you for today.